It's a great pleasure meeting you all in another video. In this video, I hope to discuss about upthrust. Before we move on to our discussion, let us look at a question. In this question, we have the same type of liquid but two different types of materials where one is floating with displacing a liquid of volume V, other one has a volume V and is sunk to the bottom. We are supposed to find the relation between the upthrust acting on them. To understand better, let us go through what is upthrust and how do we obtain its equation. So, here we come with the Archimedes principle. Upthrust is equal to the weight of the displaced fluid. You must understand the term fluid. It gives us the idea anything that is able to flow is fluid, and thus this equation is applicable for liquids as well as gases, not for solids. In this example, we have an object of volume V where a portion V dash is submerged into the liquid. According to the principle, upthrust is equal to the weight of the displaced fluid Wf. Now, mf into g, where m is the mass of displaced liquid. Thus, the displaced liquid is V dash. We have V dash rho g is equal to upthrust. We might have come across an equation that upthrust is equal to mg. So now we have two equations. Upthrust is equal to V dash rho g. Of them, which one is correct? So let's find it out. For a system to be in equilibrium, we have two necessary and sufficient conditions, resultant force being 0 and resultant moment being 0. This implies there is no linear motion or rotational motion, thus system is in equilibrium. With the above idea, let us go through these systems. First, I'll mark the forces acting on them. So, system 1, I have the reaction force R, upthrust U, and the weight of the box as mg. In the second case, I have tension T acting upward, upthrust U upward, and weight downward mg. And in the third case, upthrust is upward and its own weight mg downwards. In first case, U plus R is equal to mg as it is in equilibrium. I'll find out upthrust as mg minus R. Similarly, in second case, upthrust is equal mg minus T, and in the third case, upthrust is equal to mg. When we look at the third instant, it is clear the upthrust is sufficient to balance the weight mg, and this is observable under the condition of flotation. Therefore, this equation U is equal to mg is applicable only for flotation. With the explanation, you must be able to understand that U is equal to mg is just an equation based on equilibrium but not the equation of upthrust. So back to our question. Now you must be able to understand that the equation U is equal to mg is not the equation of upthrust, but the equation of upthrust is U is equal to V dash rho g, where V dash is the displaced volume. If you go through this question, you must be able to understand that the volume displaced in case 1 is V, and the volume displaced in case 2 has to be the volume of that object, and that is also V. Applying into the equation of upthrust, we have V common, rho common, and G common for both instants. Therefore, the upthrust U1 and upthrust U2 has to be equal. Therefore, second is the answer. I hope this video would have provided you a better knowledge on the difference between the equations U is equal to mg and U is equal to V rho g, because I have noticed this has been a very common doubt among the students. They misunderstand the equation of upthrust to be U is equal to mg. If you found this video helpful, don't forget to share.